Hello, sixth graders. One thing that I've noticed in looking at your lesson is that some of us sometimes are getting mixed up when we're trying to find the factors of a number versus finding the prime factors of a number. So I just wanted to make a quick video to help you understand the difference when we're finding factors versus finding prime factors of a number. So if we're trying to find the factors of a number like 36, when we're listing factors, that means any number that can divide evenly with no remainder into the number 36. So when we list factors, Miss Brandon mentioned that we can make a T-chart. So we could say that 1 times 36 will be our first pair of factors of 36. Then let's go in an organized fashion and let's think, does the number 2 divide evenly into 36? So 2 multiplied by 18 will give us 36. So 2 and 18 then are factors of 36. Then will the number 3 divide evenly into 36? And yes, it does. 3 divides into 36 12 times because 3 times 12 is 36. Then does the number 4 divide evenly into 36? And yes, it goes in to 36 9 times evenly. When we get to 5, we know that 5 does not divide evenly into 36 because 36 doesn't end in a 5 or a 0. So 5 is not a factor of 36. So we go on to the number 6. Does 6 divide evenly into 36? And yes, it does, 6 times. So that gives us all of our factors of 36. When we get to a number that's doubled or till we get to a factor that is listed on the right-hand side, then we've listed all of the factors of the number. So if we have to list the factors of 36, she mentioned that we could horseshoe the factors. So all of the factors of 36 in order from least to greatest then would be 1, 2, 3, 4, 6, 9. I don't have to list 6 twice. 12, 18, and 36. That is all of the factors of 36. That is any number that divides evenly into 36 with no remainder. Now let's talk about prime factors. We know that a prime factor is a number that only is divisible by 1 in itself. So to find the prime factors of the number 36, what we're going to do is create a factor tree, a prime factor tree. So we can come up and start our prime factor tree with any of these choices of factors, except we don't ever want to use 1, okay? But any of these choices of factors of 36. So we could start our factor tree with 2 times 18, or 3 times 12, or 4 times 9, or 6 times 6. I'm going to start with, let's see, which one do I want? How about 3 times 12? Okay, now when I write 3 times 12, I'm going to ask myself, are any of those numbers, 3 or 12, a prime number? Prime number means it's only divisible by 1 in itself. 3 is a prime number, so I'm going to circle that, and that means this branch of my tree is finished. I do not have to continue factoring this branch of the tree. The 12 is not a prime factor, or not a prime number. So I have to continue factoring this branch of the tree. So what are 2 numbers that I could multiply to get 12? There's multiple correct answers. I could say 2 and 6, or I could say 3 and 4. Let's go with 3 and 4. Now, look at these. Are either of these numbers a prime number? 3 is prime. So I'm going to circle it. That means that this branch of the tree can stop. I do not have to continue factoring this branch of the tree. This branch has a 4. This is not a prime number. so we have to continue factoring that branch. The prime factorization for 4 is 2 times 2. And I want to mention that when I factor that 4, 2 times 2 is the only choice. I cannot say 4 times 1 because I don't want to use a 1 in a prime factor tree. I've seen a lot of kids trying to use a 1 in a prime factor tree, but that's a big no-no. Do not use a 1. Okay, so 4 factors to 2 times 2. Now 2 is prime, so we're going to circle both of those. And now since I've circled both branches, I have completely finished my prime factorization. So I would say my prime factorization for the number 36 is, and we usually write our prime factorization in least to greatest. We'll start with the 2's. 2 times 2 times 3 times 3. And then you can check. Let's make sure that that is the correct prime factors. Is 2 times 2 times 3 times 3 the correct prime factorization for 36? Well, what is 2 times 2? 2 times 2 is 4. What is 3 times 3? 3 times 3 is 9. What is 4 times 9? 4 times 9 is 36. So that tells me that my prime factorization, 2 times 2 times 3 times 3, is correct. So I hope this video helps you understand a little bit about the differences between finding factors, there's lots of factors of a number, versus finding the prime factors of a number. The prime factors uses a prime factor tree. Good luck.